There are 1.6 million AI jobs right now. That's not an exaggeration. According to the latest global talent research, AI talent demand exceeds supply by 3.2 to 1. That means more than 3 open jobs for every single qualified person. The AI role takes months longer to fill than a traditional tech role, and they're offering 67% higher salaries than regular software positions just to compete. Meanwhile, I know some of you watching this have applied to dozens of AI roles and heard nothing back, and you're thinking that both can't be true. It is. And today I'm going to explain exactly why. And more importantly, I'm going to give you the 7 specific skills that employers are actually hiring for. And this fits perfectly if you want to get better at actually prompting AI and using these skills in practice. Check the link below. First, let me explain why the job market feels so contradictory right now. The AI labor market is actually 2 completely separate markets moving in opposite directions. It's almost like a K-shape or a sideways V. The bottom half is the traditional knowledge work. Generalists, product managers, standard software engineers, conventional business analysts. Job openings in these roles are flat or falling. The top half of that K, the roles that design, build, and operate and manage AI systems, that side is absolutely on fire. LinkedIn ranked AI engineer as the #1 fastest growing job title in the US in 2026, with job postings up 143% over a year. And here's the reality. With 1.6 million open positions and roughly about 518,000 qualified candidates, this isn't a small gap. It's a massive shortage. What are companies actually looking for when they post these roles? Here are the 7 skills that matter the most right now. Skill 1 is specification precision. It's also called clarity of intent or prompting, but this goes much deeper than that. This is the most fundamental shift in how we work with AI, and it's the one most people underestimate. We're trained to work with humans who read between the lines, who fill gaps. AI agents don't do that. They take your specification literally and run with it. If you're vague, the agent guesses, and it fails more often than it succeeds. Here's what this looks like in practice. Say you're building a customer support agent. A vague instruction sounds like handle support tickets. A specification precise instruction sounds like handle tier 1 tickets only, password resets, order status, return initiations. Escalate to a human when customer sentiments drop below a defined threshold. Log every escalation with a reason code. Here's exactly how we define and measure customer sentiment. Same intent, completely different outcome. That level of specificity is the bar in 2026. And if you've ever been a technical writer, a lawyer, or a QA engineer, you already have the bones of this skill. The gap is shorter than you think, and here's how you can build it. Start by writing instructions to an AI as if every word is a contract clause. Practice being wrong on purpose. Underspecify something intentionally and watch it fail. And that failure is what's going to teach you faster than any course. Now, skill number 2, evaluation and quality judgment. This is the single most cited skill across every AI job posting. Once you've specified what you want, did you actually get it? This is evaluation, and it shows up in engineering postings, op postings, and PM postings alike. Here's the thing about AI that catches people off guard. AI is confidently wrong, fluently wrong. When a human is uncertain, we hedge. We say, I think, or probably. AI doesn't do that. It presents incorrect information the same polish and structure as correct information. The skill here is resisting temptation to read fluency as correctness. Just because it looks right and has proper formatting doesn't mean it is right. The other piece is edge case detection. Can you look at an AI output and say, the core logic is right, but the edge cases are broken? That level of domain depth is what separates people who can evaluate AI from people who can just use it. And here's how you could actually put that into practice. Start reviewing every piece of AI output as if your name is on it. Look for the edge cases. Anthropic's engineering blog has a useful framing here. A good eval is where multiple engineers would reach the same pass or fail conclusion. You aim for that standard. Skill number 3 is multi-agent decomposition and delegation. This is a managerial skill, not just an engineering skill. The skill is really this: breaking large work into clearly defined chunks and delegating each chunk to the right agent. Think of it as a project management, except your team members are AI agents that need explicit instructions and can't handle ambiguity at all. With human teams, you can assign vaguely decomposed work and people figure it out. With agents, you can't. Every task needs a clear goal, a clear starting point, and a clear handoff condition. A proven approach is using a planner agent that holds the task list and coordinates sub-agents for each piece. For example, you might have a research agent that gathers information. There's also a critical sub-skill here, knowing whether a project is correctly scoped for the agent system you have. A single-threaded agent works best with a small, tightly scoped task. A multi-agent system with a planner can handle larger goals, but you still need to define the subtasks and their logical relationships clearly. Here's how you could actually use that in real world. You take a project you managed before and decompose it, as if you're briefing AI agents. Practice defining the handoff conditions between each task. If you've ever broken a large project into work streams, that instinct transfers directly. Skill number 4 is failure pattern recognition, the skill that turns AI builders into AI architects. Agents fail a lot, and the people who can diagnose those failures quickly are worth serious money. Here are 6 failure types you need to know. Context degradation. Quality drops as sessions get long because the context window gets polluted. Specification drift. Over long tasks, agents forget the original specification unless you forcibly remind them. Sycophantic confirmation. The agent confirms incorrect data and builds an entire wrong system around it. Tool selection error. The agent picks the wrong tool, especially when tools are poorly framed or there are too many of them. Cascading failure. One agent's failure propagates through the whole chain with no correction mechanism. And the most important one is silent failure. The agent produces a plausible looking output that is actually wrong in production. An AI agent generates a financial report that looks perfect. It has proper formatting, all sections are present, numbers formatted correctly. But the calculation logic is wrong, inflating revenue by 15%. It looks right, passes basic visual checks, but it is functionally incorrect. Nobody catches it until it's presented to the stakeholders. That's a silent failure, and detecting them requires deep domain knowledge combined with systematic verification. Here's how you could actually build it. Run edge cases, feed them bad data, and watch where they fall apart. It's the fastest way to learn. Now, skill number 5 is trust and security design. Where do you draw the line between human and agent? Once you can build agentic systems, you need to know where and when to deploy them, and where to keep humans in the loop. This is about designing guardrails, not just building features. These are core questions that you need to ask yourself. What's the blast radius if this agent makes a mistake? Is that mistake irreversible? How often does this run? And at what scale does low probability failure become a serious risk? There's a big difference between an agent that flags a potential bug for a developer to review and an agent that auto-merges code into production. One is reversible, the other one is not. Your trust design has to account for that. The key concept here is functional correctness. An LLM can say something that sounds correct while being functionally wrong. For example, this patient's dosage looks appropriate. That sounds right, but if it's the wrong dosage, it's still a disaster. You need systems that test functional correctness, not just whether the output sounds plausible. Here's how to build it. Start by mapping the worst case scenarios for any agent system you build. Work backwards from a catastrophic failure. Define what reversibility looks like. Build verification loops before you build the futures. Skill number 6, context architecture. You've built the system. You understand the boundaries. Now, how do you make sure that the agent always has the right information at the right time? Context architecture is the art of building information systems that the AI agents can reliably search, find, and use. Think of it like building a library, but the organizational system is designed for agents, not humans. The questions you need to be able to answer is what context is persistent, always available to every agent? What context is per session, needed for this run only? How do you make data objects easy for agents to find and traverse? It's going to be structured so the agent can search by product category, issue type, and customer segment. This is one of the hardest skills in the field right now, and getting it right is what allows a company to go from one agentic system to dozens. It's a massive unlock. And last but not least is skill number 7, cost and token economics. This skill shows up in every senior level AI job posting. Is it actually worth building an agent for this task? That question, and the ability to answer that question correctly, is what separates senior AI practitioners from everyone else. You need to be able to estimate the token cost for a given task. Model pricing is changing constantly. Frontier models cost more but handle complexity better, while the smaller models are cheaper but may not be reliable enough for high-stake tasks. The skill is knowing how to build a blended model strategy that matches cost to task requirement. The good news is this is basically applied math. You can build a simple spreadsheet that lets you swap in token estimates, model prices, and instantly see costs across different configurations. Most people find this less intimidating than they expected once they actually sat down with it. Most people think that you have to be an engineer, but I want to be really clear about something before I wrap up. These skills show up in engineering titles, but they also show up in operations operation titles, project manager titles, reliability roles, architecture roles, and a dozen other job families that don't have engineer anywhere in them. What companies are actually doing right now is rebuilding entire job families around agents and the underlying skills, specifying clearly, evaluating rigorously, decomposing work, recognizing failure, managing trust, architecting context, and understanding cost. Those are human skills applied to a new domain. What you're really doing is applying judgment you've already developed into a new set of tools. Now I want to break down these skills to the actual job. If you have skills 1 through 3, you're qualified for AI Operations Specialist, AI QA Engineer, or AI Implementation Coordinator. If you have skills 1 through 5, you can compete for AI Product Manager, AI Systems Designer, or AI Trust and Safety roles. If you have all 7, you're in the running for Senior AI Architect, AI Engineer Manager, or AI Strategy Lead positions. The World Economic Forum projects 170 million new AI-related jobs by 2030. So here's what I want you to do right now. Go through those 7 skills and honestly rate yourself on each one, not where you want to be, where you actually are today. Pick the one with the biggest gap and go work on it this week. Not a course, not a video. Go build something, break it, and figure out why it broke. The market is real, the demand is real, and the people who are getting hired aren't necessarily the most technically gifted. They're the ones who understand what job actually requires and went and built those skills deliberately. If you thought that this was useful, please subscribe. I make videos like this that cut through the noise and get specific. Drop a comment with which of these 7 skills you're going to work on first. I read them all. And lastly, thanks for watching. Do more, never give up, and always stay humble.